Hello everyone, my name is Qingyu. Today I will present my research about the topic of detection of undocumented buildings using convolutional neural network and official geodata in ISPRS 2021. The creation and maintenance of databases of building models have numerous applications, which involve urban planning and monitoring, 3D city modeling, as well as assisted management. However, there are some buildings which were built years ago but were never recorded via terrestrial surveying and others missing in the real estate cadastral maps. These buildings are named as undocumented buildings, and the collection of these buildings is necessary to continue and complete these databases. And convolutional neural network are favored in the urban semantics computation, especially for their task of building detection from remote sensing data. However, for the same end, the amount of trained data could be reduced if the trained models that use samples created for some areas can be implemented to building detection in another different area. This process is referred to transferability. However, due to the limited size and quality of existing public dataset, the transferability issue has not been well investigated in the current literature. The study area in this research covers 15 districts in the one-fourth of the state of Bavaria, Germany. 4 types of data are selected in this research. The TrueDOP are also photos with RGB3 bands, and the NDSM2 is a difference model between DSM and DTM. The TDSM is a difference of 2 DSMs captured at 2 time points, and DFK are cadastral 2D ground plans of buildings. And each district has many tiers of datasets, and their spatial resolution is 0.4 meters. Undocumented buildings indicate the elevated objects which exist in airborne survey data in DSM2 and TrueDOP, but are not recorded in the cadastral ground plan DFK. This slide shows the overview of the proposed framework, which has 2 tasks. The first is detection of undocumented buildings. The second task is discrimination between old and new undocumented buildings. And we first use TrueDOP and NDSM2 together at the input of the Xiang model to make a distinction between building and non-building for each pixel, and after the predicted results are overlaid with DFK, the undocumented building pixels can be identified, which relate to pixels that are assigned to the non-building in the DFK but are predicted as building from the same model. And TDSM is the difference of 2 DSMs captured at 2 time points, and with a value 1.8 meters, we are able to identify constructional changes if there is a high deviation of this pixel from year 2014 and year 2017. The undocumented building pixels are considered as new undocumented building. There is a high deviation, which indicates there is a building constructed after time point 1. Otherwise, it is regarded as old undocumented building, which means that this building was constructed before the year 2014. In the proposed framework, the abscindance net is selected as the CN model, and this is because that abscindance net has a great performance in the urban semantic segmentation, especially for the task of building detection. Our task is aimed at large-scale processing, thus, the selection of training data is investigated firstly. For the transferability analysis, 2 separate models from different sets of training data are trained to examine the transferability issues. The number of training and validation patches are shown in Table 1. Then we evaluate these 2 trained models in 2 different evaluation districts, which are Ansbach and Battles respectively. For Ansbach, the evaluation data is the same as the validation data obtained in Ansbach. However, for the district battles, the evaluation data cover the whole area. We first say the accuracy of building detection results, which are obtained by two trained models. And here we can say the evaluation results of Ansbach. The trained model 1 achieves a better accuracy, and from the visual results, we can always say that the model 1 has detected other small buildings. Then we see several visual examples of the old and new undocumented buildings detected by our proposed framework in Ansbach. And we can say that many buildings which are undocumented buildings in the DFK have been successfully detected by our proposed framework, and this has proved that the potential of our framework for the detection of undocumented buildings. After investigating the results of Ansbach, we can say the best accuracy is achieved by just collecting its local training dataset and training a local model. However, but local training is time-consuming and expensive for all cities in the one-fourth of the state of Bavaria, and we can say that difference of undocumented building detection results between the small training dataset and the large dataset is slight. Then we want to say the performance of these two trained models in battles. It should be noted that the battles excluded in neither training data nor validation data for both trained models. This is a more realistic test for the task of large-scale building detection, which could be implemented to upscale the existing training for the building detection results in the whole state of Bavaria, Germany scale. And from the statistic results, we can say that improvement of F1 score and IOU is achieved when the training data are collected from 14 districts, and rather than only in the district of Ansbach. And this figure also shows some visual examples of a comparison. Model 2 can differentiate building and non-building better than the trained Model 1. Then we investigate the results of undocumented buildings. And for the trained Model 1, and we can say the ground was mislabeled as buildings. However, for the trained Model 2, it can avoid this false alarm. And for this figure, we can also say that the trained Model 2 has detected more undocumented buildings. We then evaluate the results of battles, and the best accuracy is achieved by collecting training data from all districts in the one-fourth of the state of Bavaria. And this is because the first small training dataset might be overfitting, and training samples are more representative in the large dataset. And also the trained model from large training dataset not only can detect the buildings which are confounded by trace, but can also avoid false alarms. To conclude this research, we first carry out transferability analysis for the task of large-scale building detection, and the model which collects diverse training samples from different districts has achieved better results than that collects training data only from one district. And the second is we propose a framework for the detection of undocumented buildings, which include old and new undocumented buildings. This is because CNN has a great potential for updating building models in geographic information system. The third is that we have generated a seamless map of undocumented buildings for the one-fourth of the state of Bavaria, Germany, and a spatial resolution 1.4 meter. And this has demonstrated that CNN is robust for the detection of undocumented building at large scale.